Hi viewers, this is Sri Ramulu. So Sri Ramulu degree lecturer in physics YouTube channel is s.s space physics. So before watching this video, please subscribe it. So there are the certain networks theorems are there. So for according to degree syllabus only. So among them the first network theorem is a superposition theorem. In the superposition, for every network theorems has their own statement and later proof. So what is the statement of superposition theorem? Let me explain now. The current flowing in any resistor of a linear bilateral network containing more than one source. Here current is flowing in any resistor. So whatever resistance present in any resistors, okay, containing how many sources are there? Let more than one sources are there. So that current is always equal to what? So any source of electricity is equal to algebraic sum of currents in that resistor due to each sources calculated separately while all other sources are replaced by their internal resistances. Here let I be the current, right? I be the current due to sources more than one source is always equal to algebraic sum, means plus. Algebraic sum is let there are the two sources are there here, like this, here given two sources, and because of this source let the current is I1, because of this source let the current is I2. Okay, so here I1 current plus I2 current, their algebraic sum is always equal to the current due to all the sources. But while calculating the current, these sources from each while calculating the current I1 I2 because of the two sources. So when you are calculating I1 source, you must keep the other source, you must replace the other source by their internal resistance. And if you calculate the I2, then its opposite source you must replace with the internal resistance. Then what is the internal resistance? Internal resistance means resistance of a battery. Every battery offer their own resistance. Every battery has a own resistance. So that resistance is called internal resistance of the battery. Okay, let me start the procedure or proof. How can we prove? We have to prove the sum of the current, algebraic sum of the current must be equal to the current. In the figure, R1, R2 are the internal resistance of the sources E1 and E2 respectively. Here two sources E1 and E2 and three resistance RA, RB and RC are chosen for the sake of simplicity. Okay, so in the diagram see the what are the resistance are there. So here it is one source, second source, RA, RB, RC. So like this three resistance are there. Okay, so these three resistance, and it is E1 is a source, E2 is another source, and its internal resistance this one, its internal resistance is this one. Okay, three sources are there and their internal resistance also shown in circle. Okay, now this theorem is applicable to any linear bilateral network containing, here bilateral network, in the statement also bilateral word has come. Bilateral means two sources has to respond each other, that is called bilateral network. Two networks has to respond each other. Okay, so that is a bilateral network. Okay, sorry for this disturbance. Let us calculate the current in RA. Here my aim is to calculate the current through RA due to each sources E1 and E2 separately and then sum up the two results. Here what we have to calculate, suppose through this resistance I current is flowing. Okay, and due to both sources. Okay, now due to the E1 source, let the current is I1 is flowing through this resistor. Due to E2 source and I2 current is flowing through this resistance, then their sum must be equal to this current. This is a statement of superposition theorem. Okay. Next, let us calculate current in RA due to operator. While calculating current due to source E1, the other sources E2 is replaced by its internal resistance R2. Just now I tell you, if you have to calculate the current because of E1, then E2 must be replaced by its internal resistance. So the diagram also given. So how it is, I will show you in the diagram. See here in this diagram. Actually here also there were one more source. Now so this source is replaced with its internal resistance. Here E1, it is E1's first source, here the E2 second source were there, but second source is replaced by its internal resistance. Then current is big, now the current through the circuit because of this source only, so that current is taken as I1. Okay, but I need current through RA. Okay, for this let me once again start. Let me start. Continue. Right, while calculating the current due to E1, other source E2 is replaced by its internal resistance R2. Yes, just now. Similarly, procedure is adapted while working with the source E2 also. Okay, so now with E1, E2 is replaced by R2. If you work with E2, then E1 is replaced by its internal resistance R1. Okay. Right. So current in RA due to source E1. So current in RA due to source E1. See the diagram here. So diagram also given by beside. So here current can flow because of E1 only. Why? Because here E2 is replaced by its internal resistance. So current cannot flow with the E2. Current can flow with E1 only. Let its current is I1. Yeah. To find the current in RA due to E1, circuit is redrawn, replacing E2 with its internal resistance R2 as shown in figure. Yes, I shown just now. The total current from the source E1 is I1 is equals to. Here generally according to Ohm's law is what? Ohm's law, voltage is equals to current into resistance. But what you need here? Here you need current formula. So from this, current is equals to, if you bring resistance this side, voltage by resistance. So current is equals to voltage by resistance. Here also current is equals to voltage by resistance. So total resistance is taken here. Okay, why? Because why total resistance is taken? See here. If you see the side, the circuit, current is flowing, I1 current is flowing here, and it is flowing in RB, and at the point P, what is happening? Current is dividing. Some amount of current is flowing R2 and some amount of current is flowing in RC. Here some amount of current is flowing in RA and RC also. So that means here current is dividing at point P. Where the current divides in the branch, then we can decide those two branches are in parallel. That is the meaning of this. So that means RA and RC are parallel to each other. Their combination is series with RB. Okay. Now so here current I1 is equals to voltage by resistance. So resistance is taken RB plus RA parallel to RC plus R2 is taken. Why RC plus R2 is taken? Here current is coming and passing through the resistance RB. At the point it is dividing, part of current is flowing here and the part of current not only flowing in the RC and also flowing in R2 also. But which current is flowing in RC? The same current is flowing in R2 also. So that means same current flows means no division, current division. So where there is no current division, then those two resistance are in series. If the current division is there, then the resistance are in parallel. Okay. If current divides, then the resistance are in parallel. If current do not divides, then the resistance are in series. And see here, a current which is coming from the source 1, let that is I1. So I1 current is flowing to the RB. At the point it is dividing. Let through RA, a current which is flowing through RA, that is I1A is taken. Okay, a current which is flowing through RA is taken as I1A. And the remaining current which is flowing in RC, remaining current is what? Actual total current is I1, from the source it is coming. And part of current is flowing through the RA. Which part? That is I1A. If you subtract I1A from the total current, that this much of current is can flow through RC and RB also. So that is why here RB, here RA is parallel to RC plus R2. Therefore their combination it is parallel. So current is parallel to the combination of RC. Okay, so their combination is parallel to RA. So that is why it is a parallel combination, so formula is taken. So I1 is equals to what? I1 is equals to E1 by RB plus, and the parallel combination is what? For two resistance, first to multiply above, and in the division just add them. If there are the two resistors, A is parallel to B, then how can you write AB by A plus B? Like this you have to write. Here also same thing, right? RA is parallel to RC plus R2. So here multiplied, here added. This current I1, I1 is dividing into two parts as I1A and I1 minus I1A between two branches RA and RC plus R2 respectively. Now, both of these branches have the common endpoints, hence the potential is same across these two branches. Which branches? This branch and this branch are having the common point. What is the common point? Common endpoint means here current is dividing at point P. See here, now it is appearing clearly. Let the current is coming, I1 is coming and it is dividing at point P, and I1A is a part of current, it means I1A is flowing in RA through RA, and I1 minus I1A is flowing in RC and R2, and again these current can meet at this point. So their common endpoint is Q. Both current can meet again here and flow as I1. Okay. Next, now see here. So that is why when the common point is same, then what happens? The potential is also same. Where the potential same? Generally potential is same for parallel combination, and it is potential is different for series combination. Just now I told you RA is parallel to the combination of these two, RC plus R2. Then whatever potential here present, the same potential present across RC plus R2. So that is the formula. So what is the potential formula? Potential means voltage. Voltage equals to current into resistance. Here current through voltage across RA is equals to voltage across RC plus R2. Both are same. Why? Because these two are parallel to each other, right? Voltage is current into resistance. Here also voltage is current into resistance. Okay, this is reason why it is written like this. Now multiply this RC plus R2 inside, then it becomes like this, and it is a minus term. Bring this side, it becomes plus term like this, and take outside the common factor I1A, then you can write like this, and from this I1A is equals to, this is the formula. Okay friends, so I1A is equals to I1 into RC plus R2 by RA plus RC plus R2. This is the current in RA due to E1 source. Now we have to calculate due to E2 source, right? Same procedure. in the in E2 by using U2 source. Same procedure, but in this formula all the ones are replaced by 2's only, and RC is replaced by RB, R1 is replaced by R1, R2 is replaced by R1. That's it only. If you learn this part, half part, then remaining part is very easy. So see that part also. Now current in RA due to source R2 E2. To find the current in RA due to E2, circuit is redrawn replacing E1 with its internal resistance R1 as shown in figure. Now see, previously at this place E1 were there, E1 was there, but now it is what is happening, it is short circuited and or it is replaced by its internal resistance R1, okay, and it is open here. E2 source is capped, okay. So because of E2 current I2 is flowing. See, this current is flowing, this current flowing through RC, but at point P it is a part of current is flowing in this side, part of current is flowing. That means at point P again it is dividing. So dividing means, and see divided current, see let in RA, through RA I2A current is flowing, then in this direction remaining current can flow. Remaining current means subtract this I2A from this one, then that remaining current not only flows through RB and also flows through RC. So that means these two are in series, okay. So that is series formula, we can write RB plus R1. So this combination is parallel to RA. Same condition, same thing. Now see here, this current I2 above me, yeah, the total current from source E2 source current, total current is I2. So I2 can be written as voltage by its resistance. So I told you RC, the current is flowing RC, and at a point of P it is divided, and part of current is flowing through RA and remaining part is flowing through RB plus R1. Here see, once again, see from the source E2 current is flowing like this. So through this resistance, it is flowing through resistance, this current I2 is flowing, but at point P it is dividing. So a part of current is flowing through I2A and a remaining current is flowing through RB and R1. So that means these two are in series, but which combination is parallel? This combination, and RB's RA is parallel, it is series. So that is written here. Say, okay, so this is only written here. Okay friends, now I2 is equals to, this is like this. In I2 is what? RC, current is flowing RC, but dividing at this point, at part of current is flowing here, part of current is flowing here. That means RA and RB plus R1 are parallel to each other. So I just now I told you, when the two resistors are in parallel, then what we have to do? First multiply above and add below, okay, multiplied above and below is added. So this is the current, this is the total current from the source E2. But what we need? Current through RA we need because of E2 source. What we need? Current through RA because of this source we need. Just now what we calculated? We calculated total current with this source, but we need current through RA. So that is through RA is how much? I2A is there, right? This I2A we have to calculate here. Yes, both of these branches have the common endpoints, hence the potential is same across these two branches. Same thing here, I told you RA is parallel to this combination. That means whatever potential here present, the same potential present across this. So that means the potential across this is equals to this. Now see, so we know the voltage is equals to current into resistance. So product of current and resistance is a voltage. So here it is voltage across RA is equals to voltage across RB plus R1. So through RB plus R1 current is this much of current is flowing. See the diagram. See once again. So through RB and R2 R1 this is the current is flowing. This current I2 is divided into two parts as I2A and I2 minus I2A between the two branches RA and RB plus R1 respectively. Both of these branches have the common end point. Just now I said you common end point is this, means both current can meet at this point only, end point. Hence the potential is the same across these two branches. Now so here and multiply this factor into, then we can write like this, and ADC minus term, bring this to this side, become plus term. Now take the common factor I2A from this equation, I2A, then we write it is like this. Okay, now bring this factor that side, it divides. So finally we got, this is the formula. So this I2A is the current through RA because of E2 source, due to E2 source. In the previous already we have calculated I1A current through RA resistance due to E1 source. Okay, and now we have calculated it is also a current through RA, okay, but due to E2 source. So both current if we add, then it gives the total current. Okay, so this is the what superposition theorem. Okay friends, according to superposition theorem, total current through RA is equal to the algebraic sum of currents due to sources E1 and E2. So this is fine, hence the theorem is proved. So this is friends, so don't forget watching this video till the end. Okay friends, bye.